We had this idea, let's come up with a project where you take one idea and look at it from many, many different angles, and those many different angles actually meant many different disciplines. Rashomon was a movie that was made in 1950. It's about a crime. One crime happened. There was a murder. There are 4 witnesses, and they all have 4 ideas of what happened.
We started with a Bach piece of music, and we wondered, is there a way to teach this that isn't just in a music class? Is there a way to take this piece of music and essentially build an entire week of school around one piece of music?
My job is to tell you a bit about Johann Sebastian Bach, the composer of the piece of music you just heard. Some facts about Bach. He was German. His music is considered Baroque. Most of his music was written for a single instrument.
And now I'll talk to you more about this piece, the Gavotte en Rondeau. The title is in French and refers to a dance. Bach composed music for the dance using the violin. En rondeau is a form of this dance done in pairs.
The day that we first started talking about this Gavotte en Rondeau, the Bach piece, the kids were off in their little groups, and one of them, I don't think he knew quite what he had discovered, but over the din of the chatter, I heard his voice and he said, "Does anybody know what the golden record is?"
In 1977, NASA made a 12-inch gold-plated copper disc containing sounds and images that they thought portrayed the diversity of life and culture on Earth.
Now we will play a little bit of what was on the record.
As the Secretary General of the United Nations, I send greetings on behalf of the people of our planet.
So one of the reasons that I thought it was appropriate that we treat the Gavotte en Rondeau in a reggae kind of dub form, it almost mimics the like a popular music where you have a chorus that keeps repeating.
And what does the A section sound like? That's fine.
The form would be A, B, A, C, A, D, and A, ending up in A again.
And the B section sounds like... And it goes off and rambles in B land, and then it comes back to A again.
You have that kind of chorus element that your ears can latch onto and make you feel like you're at home. What was exciting for me was to see some of my very talented musicians get excited about other subjects through the vehicle of music.
Alright, so we're gonna switch gears and talk about some math. Fun, very fun. So this is a little thing that might not make any sense, and it's called the golden ratio. They figured out a long time ago in the ancient world, in like Greece and Rome and stuff, that that is the most aesthetically and musically pleasing ratio in all of creation.
All right, let's see how we get that golden number using golden ratio. Let's just draw a segment, any length, is equal to the length of long piece to the length of shorter piece.
So for my question, I wanted to figure out how to measure the frequency of different notes to see how they relate to each other, because there has to be, in a chromatic scale, some sort of way that they all relate. Started with like 3 chords that I really like. Mr. Dolan, will you play in A minor? Will you play in F? Will you play in C? Those are some chords I like. And what I figured out was that there are those same 3 ratios in every major chord. And in order to make a minor chord, you just change that ratio from 5 to 4 to 7 to 6. And it was really cool because it's like direct variation. We learned that in math class. Right, Mr. Neltong?
What she did in her presentation was to show that the musical frequencies, the ratios that are obtained in musical frequencies are actually based on Fibonacci numbers. And if I use the length of each square as the radius and start creating arcs and connect them, it will give us this beautiful golden spiral.
So this is the Parthenon, you might be familiar with it. It was a building in ancient Greece, and the architects designed it using the golden ratio because they knew that if they did that, it would be more aesthetically pleasing. And it worked because we still know what it is.
What we've been trying to do today is show you different perspectives. The idea of the Rashomon Project is to come at the idea of music, the idea of sound, the idea of what we're seeing from different perspectives. And I love this because, as many of you know, one of the reasons I study science, one of the reasons that I teach science is because of music, because of sound. And so all of you have been doing different projects related to waves.
I would love to do a project like this every year. I'd like to do multiple projects like this every year because it allows the teachers to really think about how the disciplines overlap, how the skills that we're using and applying in these courses overlap, and how the content that we're covering overlaps.
What I wanted to do was figure out how the length and the width of each string affected the frequency of the notes that you played. But the first thing that I did was I measured from each of the frets. There's 20 frets on a guitar, so I measured the distance from the fret to the end of the string in centimeters. This is the 20th fret, since that gives you the highest note. And this point here is at the open string. And then the heights is the frequency. So right up here we have the highest frequency that I recorded, which was 1024.6. And then here is 82.4, which is the highest on that low E string. And then on this side, you can see the widths of each of the strings. So obviously the high E is the skinniest and the low E is the fattest. And yeah, that's what I did.
The two physics projects that were presented by Sophie and Michaela, and how they used physics and equations to calculate the frequencies of the sound for each note, and basically the math behind each note, and how octaves were related to these proportions. I thought that was really cool because it's, again, something you never think about.
That process itself is, to get meta about it, is one of the things that I hope they all took away also, which is that music is not just music. Music is informed by all of these different disciplines, different aspects of life, not academic, but just everything is informed by everything else. It's a way of illustrating a connectedness.
People often ask where inspiration comes from, and my answer is that it doesn't come from anywhere, it comes from everywhere.